Let's see how to build a percussive sound, maybe a snare-like sound using additive synthesis and operator. So here's what this sound sounds like. So in terms of global settings, I have my volume set to 3.1 dB. You can adjust this. My tone is set to 100%. You can adjust this as well. My time is set to 12%. I'm going to show you this here in a second and what this does, but adjust this as well. Again, my algorithm is set to additive synthesis. This center section here is just set to all the default settings. I am doing just one voice, so this is a mono sound, a snare drum. I'm not going to get harmony or anything like that, so I just want one note to play anytime I hit a note. I do have retriggering activated, as well as interpolation and anti-aliasing. No panning in operator right now. So let me talk about this time function, and let me actually just set this to 0. And if I play a note, and what this does is it actually, it's sort of a global command for how long or short the envelope is. So if I actually decrease this a bit, so the envelope is going to stay the same, every envelope everywhere, for the filter, for the oscillator, all of those, the shape is going to stay the same. I'm just sort of changing the overall duration of that envelope. So this can be handy sometimes to adjust and actually even have modulate or something like that. So for this particular sound, I like it around 12 or 10 or something like that. If I really increase this, I mean, that's a really cool sound too. It doesn't really sound like a snare drum anymore. Or maybe like a snare drum in a really reverberant space. So maybe you like this and you want to keep that. That's great. Let me just set this back down here somewhere like that. Okay, so that's my global settings. I am using a pitch envelope on this, so we'll talk about this in a second, and we are using subtractive synthesis using the filter. In terms of the oscillators, we're actually only using 2. I have C and D turned off here. For oscillator A, let's take a look at some things here. So the first thing is the envelope itself. So I have a 0 millisecond attack. The initial is set all the way down to nothing. Decay is 356 milliseconds. Peak is set to 0 dB. Release is 458 milliseconds. And my sustain is all the way down. I'm not using any of these parameters here. Now, if I actually use, so the waveform I'm using is white noise, or noise, which white in this case. And notice that actually I don't have any control over frequency or anything like that here. So I can try to adjust these, but it's not going to do anything to the frequency. In fact, if I just solo A, let me just turn off this stuff. So it's just now. So the only thing I can really adjust for white noise is the level of that. And so I'm suggesting minus 0.9 dB. You can try some different settings here to find the right color. And I'm using that in tandem with oscillator B, and B on its own sounds like this. Now I'm using a fixed setting for this oscillator. So for this one, I'm using a looped noise sound. And my envelope is 0 milliseconds, no initial dB, 356 millisecond decay, 0 dB for the peak, 458 millisecond release, and no sustain. And that's it. So if I actually compare the envelopes for both of these, they're actually the same. So you can just copy the envelope from A into B once you create that. And so then the only other thing I'm adjusting with this, so because I actually have fixed selected, whatever note I play on my MIDI keyboard actually won't matter. It'll just trigger the sound. but it's not going to change the pitch of this. So the pitch is pretty much fixed at 50.2 hertz. And this is sort of a base frequency for our noise. So I'm going to just play, for instance, here's the note C on my keyboard. Let me just have just B. And now here's the note D and E and F, C up an octave, C down an octave. So it's not affecting this at all. So this is always going to be the frequency. Now let me just play my note C on my keyboard and then adjust this number. So find a frequency that you find interesting, and that obviously works with A in tandem. Like maybe you want more of a tom, kind of lower sound. Now there's some things happening with the pitch envelope and other things that are also, as I'm playing the note, playing with different velocities, there's some other stuff happening here. And so we need to talk about the use of the filter and the envelope, of the pitch envelope, to sort of add some variance in here. Again, if I have these turned off, that's really robotic. So let's add the filter. So a little bit of variance there. So I'm using a state variable filter. I have this set to OSR. I am using a filter slope of 12. My frequency is set to 313. I'm using 53% resonance. You can adjust these numbers as you like. You could also try different filter types as well. And now this is kind of a funky envelope, and you can experiment with different envelopes. I am starting with my initial set at 16%, not 0. So that's a little different. So it's actually starting with a filter, you know, a little bit of the filter actually being applied, and then nothing, and then it's being applied afterwards again. So my attack is 206 milliseconds. My decay is 519 milliseconds. My peak is 0%. My release is 15.7 milliseconds, 47% sustain. Now I am using this envelope feature. So if you remember, I think it was the brass instrument was using this as well. So this can adjust the frequencies as well. So this can be handy for adjusting the filter and adding some variance in there. And I'm also adjusting this here to also have the velocity of the note that I'm playing also affect the filter. So having these two, something set to not 0 here, will definitely add some more, you know, some different kinds of sounds. So the snare doesn't sound exactly the same every time. So this is a nice way to add some variance in that. And so that's what that sounds like. And then the last thing is, let's talk a little bit about this pitch envelope. And so I'm not transposing anything. The spread is set to 0%. I am using this. So again, this is a control of the overall pitch envelope. So I can set this to nothing, or I can set this up or down. So I would experiment with this. Now, what I need to do with the pitch envelope is tell it where it's sending it to. So there's the actual envelope we're applying. So in this case, it's 0 millisecond attack. My initial is actually set to minus 48 steps, right? So I can try some different things here. My decay is 278 milliseconds. Peak is set to plus 48. And release is 519 milliseconds. Sustain is 48, and my end is 48. So try some different numbers here and just kind of see if you can pay attention to what happens to that. And I am sending this to just B for now. And so I'll just, just experiment with different peaks here. As well as a sustain. Probably not going to affect it much because, particularly with a pitch envelope, we're just trying to affect the very beginning of the sound. But definitely adjust this and see what happens. So if I put this to nothing, or if I really increase it, right? So really kind of a fun little thing here, a fun patch using pitch envelope, using the filter. We'll definitely get into using pitch envelopes later when we start creating like synth leads, when we get into frequency modulation, things like that. We can definitely spend more time with this. You also don't need to use this. I actually have this turned off. Using just a filter and 2 oscillators, producing white noise, both with a pretty long attack, is pretty cool. And then even just adjusting this time. Right? Produces some pretty cool percussive kind of sounds. So have fun building a percussion sound.